Hello students, welcome to Rohit Tutorials. In this lecture, we will discuss about the introduction of Moore machine. In our previous videos, we have discussed about DFA, NFA, that is finite automata without output. We consider the DFA, that is deterministic finite automata, and non-deterministic finite automata, that we consider as a finite automata without output. Now we consider a finite automata with output consisting of Moore machine and Mealy machine. Let's look first is Moore machine. Whenever we consider the Moore machine, the output for any state, it totally depends upon the present state. The definition of the Moore machine consisting of 6 tuples, capital Q, finite set of states, summation, finite set of input symbol, next transition function, initial state, output symbols and machine function. What is this that we will see after all? Suppose if we consider this example, it consisting of Q0 state having /1, this /1, this 1 is nothing but the output at this state Q0. /1 is present at Q1 state, this 1 is nothing but the output at Q1 state. And Q2 state 0 is present, so it considered as an output at Q2 state. We consider this a finite automata with output. Finite automata with output in previous DFA and the NFA consisting of only states are present. Now the states are present with the output, also state is present with the output, here also state is present with the output. So after this slash, whatever the symbol is present is nothing but the output. The definition of the Moore machine is that the next state is decided by the current state and the current input symbol. The next state is decided by current state and current input symbol. Also, the output is totally depends upon the present state at that particular time. The output is totally depends upon the present state of that particular time is nothing but the definition of the Moore machine. म्हणजेच काय? नेक्स्ट स्टेट ही टोटली डिपेंड असते, ही पूर्णपणे डिपेंड्स असते करंट स्टेट आणि करंट इनपुट सिम्बॉल वर, आणि आउटपुट त्या पर्टिक्युलर टाइमाचं डिपेंड्स असेल त्या करंट स्टेटवर किंवा प्रेझेंट स्टेटवर. म्हणजे आपण Q0 पासून Q0 ला सपोज 0 आला तर Q1 कडे जातोय, म्हणजे ही करंट स्टेट आहे, हा करंट इनपुट सिम्बॉल आहे, आणि नेक्स्ट स्टेट काय तर Q1 आहे. या नेक्स्ट स्टेट मध्ये स्लॅशच्या पुढे जे काही दिलं असेल ते आपलं आउटपुट असेल. म्हणजे Q0 स्टेटला 0 आल्यानंतर तो Q1 स्टेटला जातोय आणि त्याचं आउटपुट आहे 1. दिस इज नथिंग बट द सिंपल Moore machine. Moore machine is represented by 6 tuples. First is capital Q. Capital Q with the help of this diagram or finite automata consisting of 3 states. First is Q0, Q1 and last is Q2 state. Capital Q is represented by Q0, Q1, Q2, finite set of states. Next is summation is there, finite set of input symbol. With the help of this diagram, it consisting of the 0 and 1 as a input symbol. 2 input symbols are there. Next transition function. Transition function capital Q, for that any input symbol is occur, it goes to the next step. It goes to the next step. Suppose if we consider there are transaction like Q0 state 0 is occur, Q0 state 1 is occur, Q1 state 0 is occur, after that Q1 state 1 is occur, Q2 state 0 is occur, and Q2 state suppose 1 is occur. These are the possible transactions are available. If suppose Q0 state 0 is occur, it either goes to suppose Q0, Q1, Q2. These are the states. Q0, Q1, Q2. Capital Q is this. Summation is this. This transition function gives you another state or the next state. Suppose that Q0 state 0 symbol is occur, Q0 state 0 symbol is occur, it goes to Q1. It goes to Q1. Q0 state 1 is occur, it goes to Q2. It goes to Q2. Q1 state 0 is occur, it goes to Q2. Q1 state 0 is occur, it goes to Q2. Q1 state 1 is occur, self loop is present, 1 is occur, self loop is present. Q2 state 0 is occur, self loop, 0 is occur, self loop. Q2 state 1 is occur, it goes to Q0. It goes to Q0. So these are the possible transaction or the given transaction available in the diagram. So this is a transition function. Capital Q, for that any input symbol is occur, it goes to next state. So next state is always from Q0, Q1 or Q2. Next is Q0. Q0 is the initial state. So this is the initial state. The symbol is represented with the help of arrow. So this is the initial state, or it is also called as the starting state of this finite automata. Next is delta, output symbol. So with the help of states, the symbol is given. This symbol is nothing but the output symbol. From this diagram, either one output is there or zero output is there. So in initial state here Q0, and the output symbols are 0 or 1. At Q0 state output is 1, at Q1 state output is 1, at Q2 state output is 0. Now next is lambda. This is called as machine function. Machine function. It is also called as the output function. What is the output for the given state? प्रत्येक स्टेट ला काय आउटपुट आहे? That function is represented with the help of this lambda. So at Q0 state, suppose output function lambda. Here capital Q is present and here output symbol is present. At Q0 state, output is 1. Suppose Q0, Q1, Q2. At Q0 state, output is 1. At Q1 state, output is 1. At Q2 state, output is 0. At Q2 state, output is 0. So this is the transition function, and this is nothing but the output function for a machine function. It is also called as machine function. So Moore machine is represented by finite automata with output, because each and every state the output is present. Each and every state is available with the output, and the transaction is given from Q0 state 0 is occur, it goes to Q1 and output is 1. Q0 state 0 is occur, it goes to Q1. For Q1 state output is 1. Likewise, we have represented the Moore machine with the help of finite automata by considering the output. If suppose we provide any string, to this finite automata, suppose 0 0 1 1, suppose 0 0 1 1. So length of the string is 4. Whenever we provide this string to this finite automata, it gives you output which consisting of length is 5. Suppose if you provide n length to this finite automata, n length string to this finite automata, it gives output as n plus 1. How? Let's switch it. Whenever we start with the Q0 state, whenever we are at Q0 state, there is no any transaction is available. Means suppose if you provide empty string to this finite automata, it goes to Q0, and when it reaches to Q0, the output is 1. Output is 1 suppose. At Q0 state, suppose 0 is occur. At Q0 state 0 is occur, it goes to Q1 and output is 1. At Q1 state 0 is occur, it goes to Q2 and output is 0. At Q2 state 1 is occur, it goes to Q0, output is 1. And last, at Q0 state 1 is occur, it goes to Q2, output is 0. Means without having any transaction, if finite automata at Q0, it gives you output 1. If you provide empty string, that is epsilon, to this finite automata, it reaches to the initial state, and at initial state the output is 1. This is nothing but when we provide a string of n length, it gives output as n plus 1. म्हणजेच काय? जर या फायनाइट ऑटोमेटाला आपण n लेंथची स्ट्रिंग जर प्रोव्हाइड केली तर आपल्याला आउटपुट येतं n plus 1. का बरं? कारण आपण ह्या इनिशियल स्टेटला जेव्हा पोहोचतो, एम्प्टी स्ट्रिंग घेऊन पोहोचलो तरी सुद्धा आउटपुट 1 येतं. म्हणजेच हा काय झाला, हा जो +1 दिसतोय, दॅट इज नथिंग बट द आउटपुट ॲट दॅट Q0 स्टेट. So if you provide 0011, so output that we are getting is 11010. This is of length 5. So this is all about the Murray machine. Murray machine consisting of output or the next state. Next state is totally depends upon the current state and current input symbol, and output is totally depends upon the present state at that given time. So this is about a basic or the introduction of Murray machine. I hope you understood this. Thank you.